Hello everyone, welcome to the channel Happy Learning. Today we'll learn SQL by using the ACID properties. We'll get to know about the ACID properties. These properties are very important properties as I am an Azure SQL certified professional with around 14 years of experience in IT industries. So as per my experience and knowledge, if you are a professional or experienced or fresher with less experience or with no experience in SQL, or you are a student or you want to go apply for your any exam, or you want to go for any certification exam related to the database, these property of acid with DBMS is really very important property, and almost 90% being asked in either in examination, certificate examination, or you are going to crack any interview. So I'm sure about 90% of the cases are here when you are going to face or being asked about this question, what are the acid properties? So without wasting even a single moment, let's get started about the acid properties. So basically, if I say there is no as such any acid in SQL, it's kind of like abbreviation which makes it an acid. Like A stands for atomicity, C for consistency, I for isolation, and D for durability. We'll go in detail about each and every of these property in deep, but at very high level, atomicity means each transaction is all or nothing. Now the question arises what the transaction is. Transaction, let's take an example. If you are going to a bank for depositing some amount of money, so your accounting your account is being credited with X number of rupees, X amount of money, then this is called the transaction. You have done one transaction. Another example, if you are going to take withdraw money from ATM machine nearby your place, then you are going to make one transaction of that. Means this kind of transaction. Transaction is another different topic in so we can cover that in SQL in later stages, but very high level you can imagine yourself by these kind of transactions. So atomicity related with the transaction, what it says that each transaction is all or nothing, means whether it will be 1 or it will be 0. We'll explain this stuff in detail in later stages. C stand for consistency. Consistency means data should be valid according to all defined rules. In last lecture also we have we have learned about the constraint, different constraints, primary key constraint, unique, default constraint, check constraint. If you have some idea of it, then it is really good. And if you want to learn about it, then please go to our last video where you will get clear knowledge of all these terms. So these are the rules which we define while creating a table. So consistency means data will be there in the table with following all the rules. We'll go in detail in our next session. Then isolation. Isolation means separate from each other. Isolation, again we are talking about the term transactions, means when number of transactions are happening, they are not going to affect each other. But how this happens, we'll go and study this in later stages. Then the last one is D, durability. Durability means committed data would not be lost even after the power failure. See, if you have credited X number of amount of money in your account, then your balance would be upgraded from X plus Y plus X amount. Y your previous account balance and X is the new account balance. So it will be there as it is until unless there is not any other action performed on your account. So durability means it is not going to lose any of the information even if the power failure happens. Then how it is possible? We are going to study this in our next topic. Next slides, later slides. So acid properties, A stand for atomicity, C consistency, I isolation, and D durability. Just imagine everything related with the banking system, transaction. Just portray these kind of images in your brain while we switch to next slide. So what is atomicity? Atomicity means all or nothing rule. There's one all or nothing rule. What is this rule? By this we mean that either the entire transaction take place at once or does not happen at all. Means you are going to withdraw your amount from ATM machine, either it will take place or it is not going to take place. There is no midway. No midway means, let's take an example. If we are going to withdraw, suppose 1000 amount of rupees and 800 get into your hand and 200 you did not get. So there is no kind of partial transaction happening. Either you'll get all 1000 rupees or you're not going to get any of the amount. So the transaction does not occur partially, means it is not splitting in any way. Each transaction is considered as one unit and either runs to completion or it is not executed at all. It involves following two operations. As I have given you one example, either your transaction will be fail or abort, or it will be complete, successful or committed. Means these two operation, abort or commit. What are these two? These two are, if a transaction aborts, changes made to database are not visible. Means your transaction is fail. You are unable to get money out of your ATM because of XYZ reason. So your database, means your amount or your account is not being changed. Or commit. If a transaction commits, means it is successful, changes made are visible, means you get 1000 rupees, means your account will get minus by 1000. Let's take an example, debiting and crediting a money transfer. If we talk about debiting and crediting in a money transfer transaction, both must happen either together or not at all. Let's try to understand this concept by this example. Suppose person A is going to do some kind of transaction, money or fund transfer to person B. Before transaction, the person A was having $30. He debited $10. And now if the transaction is successfully, he must have $20 amount left in his account. Transfer process happens and it gets success. Before the this transfer happens, person B was having $100 amount, it get credited with $10. Now the available balance is $110 with the person B. Debit successfully happens, credit successfully happens, means both the way it goes. Complete execution, this is atomicity, and execution is successfully. But if because of any XYZ reason this transfer does not happens, this transaction does not get complete, what will be there? There will be no fund transfer. It will be partial execution, means no atomicity, and execution is terminated, means it is not going to credited or debited any of the bank account of person A or person B, means it have to be completed 100%. There is no partial way, there is no partial execution. Next, what is consistency? And a second part of ACID, ACID. First one is atomicity, we have covered that. Second one is the consistency. Consistency is when we have to maintain the integrity constraint so that any given database stay consistent both before and after transactions. Let's try to understand with an example. Suppose person A is having 500, you can say rupees, dollar, euros, whatever the currency you want to understand. You just imagine that. Or the person B is having 200. Some transaction happens. Transaction T1 happens with person A and transaction T2 happens with person B. Let's focus over transaction A. Transaction A T1, read A means we are going to read A, that is 500. A becomes A minus 100, means 500 minus 100. Write A. What will be left? It will be left with 400. Transaction T2. Read B. B plus 100. These 100 amount get in addition with the amount balance of this B. Write B. B will be 300. What the integrity constraint tells? It tells the sum of the balance of these two would be same if the transaction is consistent. If we refer the example discussed above, then we have to maintain the total amount before and after the transaction. Transaction happens between A and B. This is A and B. X amount of transaction happens from A to B. If I talk about the sum of these two, before transaction it was 500 plus 200, 700, and after 400 plus 300, 700. This is what the consistency is. Total balance should be the same, means integrity constraint should be maintained. Next, isolation. The third property is isolation. What does it say? It says, let's take an example first. This is the initial stage. Isolation comes into the picture when we are going to perform more than one transactions at a single account or a single system, means the concurrent transaction. Let's focus over this picture. This is the initial state. Initial state, concurrent transaction. Concurrent means more than one at a same time. Suppose this is transaction 1, 2, 3, 4, 5, 6. All these are coming to this account at the same time. So what happens at the final stage? It will be at this point. Means there was having only 2, 1, 2, 3, 4, 5, 6. All get summed into this, and at the final stage there will be the X amount or the, or if we are talking about the banking system, or all, it will be the result of all these transactions at the final stage. Isolation is achieved through locking exclusively and shared way. So let's try to understand. The transaction occurs independently and without any interference. How it is going to happen? This is the question which comes into my mind or in your mind. So isolation is the ability of the database to concurrently process multiple transactions in a way that changes made in one does not affect the other. A simple way how we have to make a data structure and variable thread safe and multi-threaded. Concurrent environment means we have to use the thread process. If one thread is going on, another need to be hold until unless first one is not either committed or it is rollbacked. The transaction before altering any row takes a lock shared or exclusively. There are some other terms which is coming into the picture, the lock. What are these locks? There is again a very huge topic, but I'll let you know a very high level of picture. Whenever we are performing any action to any account or any row, it get logged. Means until and unless that transaction is not happened. Transaction means if I'm talking about a row of a table, means transaction, any kind of updation, insertion or deletion is not being performed over that being logged, and either that transaction will be commit or that will be rollback. Until and unless these both results are not received, the next transaction which is in queue, that has to be on hold, and as soon as the first transaction get complete, second one will get executed. In this way the concurrent transactions performs, disallowing any other transaction to act over it. The other transaction might have to wait until the first one either gets commit or rollback, as I already explained. So let's take examples, a few examples when 500 slots are available in any hospital system, an online system, booking system is made. So what will be there? Maximum of 500 people can book their slots. When some mobile company, like any example you can take, they have a fresh sale of suppose X amount of units. They have to ensure that order should not get received to X amount what they have taken, as I have taken 1000k units. And the same way, if we are going to book a flight seat, suppose 130 capacity of passengers, so it should not be able to book 140 or even 131. It is limited to maximum 130, or Or more simplify, more easy example, you are going to book like a movie theater, you book online system, you get the tickets, it get vacant, it get booked. But this is the same way how the first transaction is not dependent upon the another one, and until unless sometime if you see before 5 minutes a seat was booked, but after 5 minutes it get vacant, if you are booking some movie ticket or something like that. So just take an example of that. So these are the isolation. Next property and the last property is durability. Durability is the term ensure that the data after successful execution of operation become permanent in database. Means suppose you have $100 in your amount in your account, and someone get add $10 into it, you'll get $110, and it will be $110 until unless you are not going to perform any other transaction, or bank is not going to perform any automatic transaction like interest debited or some kind of like transaction happens, bank loan automatic transaction. So it will be durable, means it will be there as it is and the permanent. And the durability of the data should be so perfect, even if the system fails or lead to crash, the database still survive. Means if the server get burned because of some electricity reason, or there is some crisis happens like some cyclone comes and they destroy each and every physical system and everything, like then still the database need to be survived. Means your account amount should not get affected because of any physical environment or any geographical reasons. So the question arises how this happens. Let's take a look over the algorithm, how it works. The isolation, let's take an example. Let's try to understand this. This is the state one. State one, let's consider this is your account. Some changes applied to this. Suppose you have $10 or sorry, $100. Someone get 10 more dollars into it, and your amount will increase from 100 to 110. Now this was the stage one, and this is the stage two. Here you were having $100 and now you are having $110. Changes applied to your account. Meanwhile, what happens? Transaction logs get locked. Means each and every transaction which you are going to perform, or which is going to perform on your account, that is being logged. Logged means the third terms which comes into the picture. What is logging? Logging means will get note each and every transaction whatever is going to happen on your account. Means if it is getting debited, then it is going to log. If it is getting credited, then it is going to log. If you are going to perform 10 number of operations in one day in your account, there will be 10 entries. If you are going to perform 100, here will be 100 entries. If you are going to perform n number of operations, there will be n number of rows in the log. So these are called transaction logs. And these are non-volatile storage, means it is not going to destroy. So whenever some stage comes when the system get crashed, means your system is not available, then how we are going to retain your this stage $110 of your account? So we'll take help of this transaction log. We'll try to reboot everything from this transaction log, and you will get your account back from state 2 to state 2 without effect of this crash. State 2 is reconstructed and fully recovered using transaction log. Durability is often achieved during separate transaction logs, and that can recreate all transactions from some picked point at a time and within a time. Just imagine kind of backup. So with this, we have done progress over acid properties of DBMS. which is the atomicity, consistency, isolation, and durability. I hope you would like this session. And if you have any question related with that, you can ask either in comment, and please subscribe the channel or share or like or comment, whatever is your choice, so that we get motivated to help you in any way we can do. Thank you so much. Have a nice day.